This is course 416, and what I'll be giving to you for this morning is more of like an overview on what the course would be offering. So this is actually more of like offering a foundational aspect on what artificial intelligence is, and to that, an extension of one of its branches, which is machine learning. So here, we're going to be learning in the next 1.5 hours or so. We're going to be deep diving a bit on these two topics and how they are related with each other. Now, having said that, before I can even begin, we all know what artificial intelligence is nowadays, right? I mean, if we're going to compare the sudden upsurge of its popularity, not just in the academy, but even in the industry, we can immediately already see that there is a growing interest on this technology. And having said that, no, we need to also have a bit of a step back on how do we even perceive AI in the first place, right? So immediately right now, we perceive it as a technology or the idealistic view on what AI really is, right? This is also another enabling technology for us that would allow us to take it one step further still into an idealized, somewhat borderline utopic society wherein uh, artificial intelligence is already benefiting from society in the bigger picture, right? But again, because also on how we portray artificial intelligence, there is also a growing fear and a growing stigma on its possible disadvantages and as well hidden fears on because this is a technology that somewhat already mimics human behavior and to that extension, humanity in itself. Are we already taking things a bit too far on how can AI be seen as something that is already socially acceptable in general? I mean, when we are already stepping in, I mean, there is already a growing perception that, okay, we have already started the age of Telnet, if I'm not mistaken, or no, not Telnet. I forgot the name of this movie, no, but this is for Terminator 3. Skynet. Skynet. Are we already going there already? But if you're going to look at it from a scientific perspective, especially the one that we're going to be talking about today, AI is more of like a series of calculations, mathematical calculations, and even statistics, no? Implemented with a bit of programming itself, right? And this is how us engineers and analysts and data scientists perceive how AI really is from a practical standpoint, especially nowadays. But of course, to us who are not yet keen on what the technology is, no, there is already also a growing, I don't want to say niche, but more of like a another perception on how AI is being seen nowadays. I mean, especially now that generative AI is already a thing, specifically for um, image generation and even text generation. And we can often see it as something that is also worth laughing at because we are definitely far from what we are perceiving to be as an impending fear of what AI can offer in our society in general. Right? I mean, just look at this picture nowadays. And if you are able to see also in social media nowadays, also if you have seen the ever-growing memes of generative AI, especially also in video, no, we can utterly say that we are still a bit far off on what its possible outcomes would be, no, related to how media perceives it, right, as something that is borderline dystopian. Now, enough about that, no. We'll now discuss now what is AI in general. So we're going to be defining. I've presented to you here some 6 topics on what the next hour and a half of what my discussion will be about. So I'll be briefly discussing here what is AI, artificial intelligence. I'll also talk to you briefly on the history of AI. Even though its popularity has grown in some around the early 2020s, no, we can even trace it back as early as the 1950s or 1940s, no? And I'm going to show to you also some milestones on what are the contributing technologies that has made also AI to be a thing nowadays. No? We're also going to be briefly discussing here the different branches and subsets of AI. Although this is a topic that is somewhat geared towards programming, mathematics, statistics, and the sciences, we can also see this as also a topic that can even expand or broaden further towards governance, towards humanities, towards ethics and the arts. No? And we're going to be briefly also touch on what are the other fields that artificial intelligence is also involved on. Next one, we're going to be defining what machine learning is. So this is a branch of AI that most of the analytics and data scientists are clearly focusing on. And then we're also going to be discussing the different techniques and use cases of machine learning. So, right, just a few minutes ago when Kahoot was, or when you took your pre-testing Kahoot, there are already some keywords that have already popped up, such as what is supervised learning, what is unsupervised learning, what is artificial neural networks, no? So we're going to be discussing here. And then lastly, because AI, we perceive this as a technology that is very promising. Let's also take a step back again and see what are its current challenges and limitations. So, what are the difficulties it is experiencing as a technology, especially when it's already being used in society broadly. Okay. Now, having said that, what is AI, artificial intelligence? So there are several textbooks and definitions on how you can truly define what AI is, right? So there is no specific definition for AI as like all other technologies are, right? Um, there are, however, some key terminologies or key terms that you might want to look into to say that this is a definition of AI. So first one that I have seen is this is the ability or the given ability of a digital computer or computer controlled robot to perform tasks associated with intelligent beings. Note here the term intelligent beings. Oftentimes, we perceive artificial intelligence to be also associated to human intelligence. But if we're going to look at it from different sources or even different textbooks, we can even extend this further to be artificial intelligence. It is the development or giving machines the capability for it to mimic, okay, or to perform tasks by intelligent beings, also including here animals, right? Plants, no? So it's not just limited to your typical Homo sapiens. Okay? Another definition here, artificial intelligence is the simulation of human intelligence processes by machines. So in such a way that we are giving again machines the capability for it to simulate human intelligence. Take note here also of the term simulate. It's not like we're going to replicate already. We're going to be creating a somewhat synthetic human being that we can already perceive as something to be human, right? Specific applications of AI, this already includes expert systems, natural language processing, robotics, speech recognition, among others. Take note here also that even though most of the, or the common trope nowadays of artificial intelligence is that it's also associated to robotics or to robots, meaning it involves the creation of mechatronic systems that is in the form of a human being, but it goes beyond that. No, AI can also be perceived as something that is mimicking human intelligence alone, meaning the possible cognition or how humans perform mathematical calculations in order to have a perceived knowledge or perceived understanding on the different aspects of human intelligence, such as speech, language, no, computer vision, among other things. And again, going back to my topic a while ago, or to my point a while ago, this doesn't just even be limited to human intelligence. It can even be extended to, say, non-human intelligence such as animals, right? So if you're going to see here, um, you can create a model that is able to mimic the behavior of a cat or a dog, like for instance. Okay? So there are different aspects of artificial intelligence in general. So I'll be naming here some of them. No? So first one, problem solving and decision making. AI systems can analyze information, identify patterns, and make decisions based on how they understand and perceive their external world. Right? This also enables them to perform complex problem calculations rather, and perform tasks that are traditionally requiring human intervention. This is also where, if you're going to think about it, no, AI already is more of like, although it is an improvement of human intelligence, take note that it is still inclined towards human intelligence. This just means that whatever you program a given AI system, it is only limited to whatever it is that you have programmed it to perform, right? So say, for instance, you develop a model that is able to um, understand human text, that it can only perform our human text understanding. If you created a model or a system that is just able to move its head, no, and um, have vision, peripheral vision, no, in the form of, say, a robotic head, for instance, or a robotic bust, no, you can only allow that system to do that. Okay. So another aspect of it, so putting problem solving and decision making one step further, another aspect of AI here involves the ability to learn and adapt. Okay? AI systems can learn from data and experience, much like what a human being or an intelligent being can do. No? This learning can be achieved through various techniques, and it can be implemented in the form of mathematical calculations. So you'll notice here that I am pretty much stressing out or putting into importance here the mathematical aspect of artificial intelligence. It's because it is, no? Um, we are still not yet on that stage of AI advancement wherein mathematics and science can already be removed completely from AI. In fact, it is still highly dependent on a computer model or an artificial system can only do so much, no, based on whatever mathematical calculations it can perform. No? Now, these mathematical calculations, of course, unlike your traditional means of just performing it in one formula or one static formula, an AI system is able to adapt such that based from the data that you feed it, it can also adjust whatever calculations that it can perform and produce a response based on that said output, right? So if we're going to make this akin to a human being, this is where your experience would be coming in, right? I mean, everybody here has already learned that fire is hot and it can burn you based on experience. Nobody is able to learn here that fire is hot just because somebody told you. You have to learn it also by experience in some dire consequence or another. No matter how big or small it is, we experienced how hot a fire can be. And although it comes in the form of sensory touch, no, and of course through pain, no, an AI system learns differently such that you feed it with data, no. Complex AI systems can even go into the extent of wherein you train the model based on a punishment and reward system in order to drive it towards a perceived result, no, or a desired result. Okay? So another aspect of AI is imitating perceived human intelligence. So while not achieving true human intelligence, AI systems can exhibit human-like capabilities. So this is where your aspects of androids, human-like humanoid systems, or robotics will be coming into play. wherein these machines, although we can see it as something that is human, we can look at it and say that it looks like human, but is it truly human? Okay, so for now, we haven't yet raised or been in that state of saying that it is fully sentient. No? The most that we can do right now is that it can be perceived to be sentient just because it is able to exhibit human-like behavior such as vision and heck, you can even go beyond wherein the AI system is able to give you emotional expressions if you give it a human face, right? Okay. And then the other one is environment interaction. So AI systems, for it to perform problem solving, decision making, and adoption rather, it should be able to have a means of receiving stimulus from the outside world. So this is where environment interactions would become. This comes in the form of, if say we are talking about the physical space or the physical world, this can be seen as something, or this can come in the form of equipping sensors to your physical system in the form of, say, your actuators, temperature sensors, a web camera, no, or or a mic so that it can perceive sound, no. And in the computational space or in the logical space, this is where your input variables would be coming in. Okay, especially in machine learning, this is where your features would be. Okay, this allows an AI system to gather information, manipulate whatever objects that it has, no, and navigate in whatever world or space you give it into. Okay? Excuse me. Now, a brief history on what AI is across the years. As I have mentioned, no, although nowadays we can perceive AI to be popular or it has gained traction in the early 2020s, it actually spans as early as the 1950s. And heck, it can even go back still on the early 1940s. So despite the boom of AI during this year, no, especially during the pandemic, wherein OpenAI introduced their ChatGPT platform, no, or chatbot, the science itself has already been there since the early 1950s. And there are even some references and sources that even say that when the first semiconductor was first developed, this is also where the time where AI was even developed, no? And there were even some sources that even trace it back in the early, I should say, in the early histories during the classical period, wherein there is already the question of what makes human human, right? Because that is already being perceived as something like we are already starting to question our own existence, and is it possible for something that is non-human to be uh, sentient, or is it possible that a non-human also exists in a way of how a human is able to think and understand? Somewhat philosophical already. But still, no? If we're going to go back into the science here, no, it goes really way back. Okay? So, AI as a science covers more than computer science and even robotics. Okay? Even though we can see that this AI is a field that is somewhat within the STEM field, or the STEM line of studies, or STEM or sciences, no, wherein we have already here computer science, computer engineering, electronics engineering, no. It can even be span, or it can even span across several sciences as well, or not even in the sciences, but even in the arts, no. Remember that artificial intelligence involves the creation of a machine that allows it to have or to mimic human intelligence. And definitely, humanity doesn't just revolve around performing mathematical calculations. I mean, some of us, in fact, are proficient at it, but remember that the whole human experience also involves arts. It involves also philosophical thinking, no? It also involves languages. So this is also where AI can even branch out. Okay. Now, it just so happened that for us to create artificial systems, the science that is somewhat associated with it is, of course, computer science, right? But remember that we can also apply computer science to AI across other different fields and professions. Okay. So practically speaking today, however, if we're going to, or the common industry and even academic term for AI, whenever we say that something is AI driven, normally this is already associated to computer sciences, no? And especially on the topic that we have today, no, it is when we say AI, the first thing that comes into association with it is machine learning. Okay. So just a quick recall that AI in general, this is a broad science. Okay, it covers several topics. It covers several branches, in fact. No, and the one that we're going to be discussing here, no, is just a tip of the iceberg of the AI iceberg. If you want to put it at that. No, and the one that we're going to be focusing more on solely for today's session is on the machine learning aspect. So recall that AI, this is a broad field of computer science concerned with creating intelligent machines, okay, capable of performing tasks typically requiring human or non-human intelligence. Okay. Now, machine learning is a subset of AI. And I say here that it is a subset because it is still AI, but it doesn't really much focus more on the aesthetics of it, but more of like the logic behind it. Okay. And what do I mean by that? No, this is a field of AI focused on developing algorithms that can learn from data and improve their performance on specific tasks without explicit programming. In other words, machine learning involves creating a model that is able to feed on with data, whatever type of data that you give it, no? And based on the data, able to see a specific pattern or trend and from there produce a desired outcome. Okay. Now that output can be something that is categorical or otherwise, or it can even be a pattern. No? So still, the objective of machine learning here is to learn from data. Now, how it can learn from data, of course, we have two different categories for later on I'll be showing. Now, taking it one step further still, an approach to machine learning wherein you are already, because the creation of a machine learning model can involve several paradigms and several approaches. And one of the most talked about approach is deep learning. And I say that this is an approach to machine learning because yes, the objective here is still the same wherein you create a system that is capable to learn from data. The only difference with deep learning is that how does it learn from data? Okay. Does it learn from only explicitly deriving a function and from this function it is able to produce a result? Or do you implement a different function, a different formula, or rather an architecture on how it can handle the said data? So in deep learning, this is a subfield of machine learning wherein the architecture is somewhat different or a paradigm or how you approach data processing, it's different. Because instead of just deriving or relying on a specific function, you lay out your data in what's called an artificial neural network. And later on, I'll be briefly discussing also what an ANN is. But it is inspired by how a typical neuron is structured, and it utilizes said neurons in order to create an ANN, an artificial neural network, with multiple layers in order to handle complex data. Okay, and its main objective still, no, it's somewhat also tied to machine learning in order to identify intricate and hidden patterns. Okay, so for machine learning, as I have mentioned, um, your model is able to learn based on the type of data you feed it with. right? And there are two techniques on how you feed that data. We have what's called supervised and unsupervised. Now, how does it differ? No? Later on, I'll also be discussing what is supervised learning. But for now, the most common approach to supervised learning, we have two most common approaches or applications on supervised machine learning. This is what's called regression and classification. Whereas for unsupervised learning, we have clustering and association rule. No? Now, keep in mind that there are also some textbooks and some references that also go beyond and even overlap these techniques, right? I mean, it's possible for you to implement regression using unsupervised learning or clustering using supervised learning and vice versa. Okay, but based on the common references that I was able to gather, no, these are the four most common techniques categorized into two umbrella techniques. Okay, now let's first discuss what is supervised learning. So this is an approach in machine learning wherein a model is given labeled data and you also tell it to produce a specific response based on the said labeled data. Okay? A supervised learning algorithm takes a known set of input data and known responses. So meaning you are already feeding it with unexpected input and unexpected output. Okay, if you're going to look at it from a programmer's perspective, no? And using these two input types, no, train a model to generate reasonable predictions for the new response to the new data. Okay, so here's a typical supervised learning workflow. No? Suppose say I want to create a simple model that is able to identify if a given four-legged animal is an elephant, a camel, or a cow. No? So in supervised learning, there is what's called labeled data, meaning that you have a given data set that it already has the qualities or traits of what you want it to be labeled into or what's the possible output. And aside from the input raw data, you also have training data. Okay? So, training data can also be associated to your labels. So, meaning you already feed the model with, say, okay, if a cow if a four-legged animal has horns, no, has others, and it is also able to produce milk, no, and it is normally domesticated, then we can say that this is a cow. Okay. Notice those traits that I have already given where it is four-legged, it has others, it can produce milk, and it is domesticated. No? In data science, these are what you would call characteristics, no, or features. Okay. So based on these features or characteristics, no, this is what the model would use in order to identify the actual input raw data. Okay. So if you give it, say, so you also tell the model that, okay, um, if you see a four-legged animal or if the data set contains a four-legged animal, has a hump on its back and is normally found in deserts, no, you can say that this is a camel. Whereas if it is a four-legged animal, it is normally found in forests or jungles and it has a distinguishable long trunk, you can say that this is also an elephant. Okay, so based on these characteristics, you feed it into your model, and from these characteristics, now aside from this labeling, you also give it training or sample data. Okay, and tell it that, hey, okay, so this is a data set that contains it is four-legged. Okay, it has others. It can produce milk. Okay, it is domesticated. This is a cow. Okay? And if you see any of these characteristics in your data set, this is already also a cow. So that is, if I'm going to simplify how supervised learning is. Okay? The key point here is that in supervised learning, you tell the model what it should produce as a response. Okay? Now, there are two classifications on supervised machine learning. Notice that even though I give a four-legged animal as my example, no, what we are actually implementing there is a means of classification. We are trying to classify our data from known characteristics, no, based also on the trained data set. Okay, so that is classification or a use case on how supervised machine learning is done. Now, another approach or another classification of machine learning, no, is regression. So, this is a type of supervised learning that is used for prediction. It is used to predict continuous values such as house prices, stock prices, or customer churn, among others. No? Regression algorithms learn from a function that maps from the input features to the output value. If you have already taken your mathematics already, or even in your statistics, we have already encountered what regression is, right? In math speak, no, if I were to tell it, no, this is where your formula y is equals to mx plus b would be coming in. The very I would say infamous formula normally used for regression, because you have there the slope and also the intercept. And this is no exception. No? This same formula is in fact also being used in machine learning regression. So you are still relying on a mathematical formula. The only difference here is that the mathematical formula is implemented as a model. Okay? Unlike your typical math that you have here also your function, and there you go. No? So regression is normally used for, as mentioned here, continuous values. So meaning that in a typical example time series data wherein your data set is also related to time. For example, if my house prices for August is X number of peso, and September is X number of peso, how much, based on these two data sets or data points, no, what will be the predicted or estimated value of my house price come October, November, December? Okay, so in other words, you can use regression in order to project and predict possible data sets based on historical data sets. So in other words, you use the historical data sets as a means of training in order to identify future values. Okay, so that is regression. Now, the other approach or other technique for supervised machine learning is the one that I mentioned a while ago about your camels and cows and elephants, no, classification. This is the process of finding or discovering models of or functions that helps separate the data into categorical classes. In other words, you are already dealing with, unlike in your regression wherein you have continuous values, classification is normally used for discrete values. In classification, data is categorized under different labels. According to some parameter or some characteristic, you give the model as a means of truth. Okay? So meaning, it is somewhat also like regression in a way, because you feed it with a training data and you also give it with characteristics in order to identify a result, but only difference here is that the type of data you are handling. Normally in classification, as I mentioned, classification is to discrete, whereas regression is to continuous. So you can put that somewhat analogy here. Okay, so these are just two of the most common approaches into supervised machine learning. In fact, the most two common ones. No? Now, let's go into unsupervised machine learning. So, in your supervised machine learning, you have your data set, you also have your labels, and you also have your training data. And based on that training data, correlated to your labels or your characteristics, you're able to produce or gain more insight based on the actual raw data that you want to work with. So you can say that another analogy here is that you can think of supervised learning as sort of like your typical classroom setup wherein you have a teacher and then that teacher feeds you information, they give you information, and then they also tell you that based on the result that you have given, no, whether you are quote unquote correct or incorrect. Okay, so that is supervised learning. Unsupervised learning, think of it as sort of like you are self-studying. Okay? So meaning that yes, there is still data being involved and there is still training being done in the given model. But in unlike your supervised learning, no, the task of the model is to group unsorted information according to similarities, patterns, and differences without any prior training. Okay. Unlike in supervised learning, no teacher or training data is provided. That means no training will be given to the machine. Therefore, the machine is restricted to find hidden structures or hidden patterns within the unlabeled data itself. So, using also again my example a while ago, no, you have your four-legged creatures here, your elephant, your camels, and then your cows, no. Um, Based only on a specific threshold or specific parameter, no, you can tell the model to say that, okay, if a certain data contains or has breached this parameter, you can categorize it into something else. Okay, so think of supervised learning as sort of like, yes, you are still teaching the model to do something. But unlike wherein your supervised learning, wherein you are literally cuddling your model, wherein you are holding it by the hand and telling it what should be and what not should be the correct answer. In supervised learning, you just give it a threshold, and based on that threshold, if it is breached or otherwise, no, it would produce a result. Okay? So, in unsupervised learning, so just to balance it out also, I have also identified here the two most common classifications. You have clustering and association rule. Okay? Think of clustering as sort of like your classification in supervised learning, wherein based on a given threshold, no, um, the model is able to group together some data sets and identify a specific cluster based on how the data sets are grouped together. Okay. Clustering algorithms work by iteratively moving data points closer to their cluster centers or further away from data points from other existing clusters. Okay, so here's a typical illustration that you would find nowhere in you have data sets, and you would see that there are some data sets that would be jumbled together or grouped together that is already considered as a cluster, right? So based also on a threshold, you can also tell the model how many clusters that it should produce, right? So a typical algorithm used for clustering is the k-means. No, it is also the simplest, the k-means clustering, wherein the k here stands for the number of clusters that you want the model to produce. So if your k here is equals to 1, then it would just group your data sets into one cluster. If k is equals to 2, it can split it into two clusters, and so on and so forth. Okay. Keep in mind also that in clustering, no, as also I have shown here, no, just because you are clustering data sets together doesn't mean that you are already you are expecting to see a somewhat uniform shape, such as in a circle. Okay. So it depends on how the model is also able to understand the threshold that you have given it, as well as the data points that it is trying to work. Okay, so here's an example, so an illustration. Now, the other one is association rule. This is a type of an unsupervised learning technique that checks for the dependency of one data item into another data item. Okay, so the keyword here is association. So it's somewhat similar to regression wherein you are working with characteristics, but in association rule, no, the characteristics are correlated to another. So just to give you an example, here's a simplified illustration for it. Say for instance, I am working with four customers, and these four customers have their own shopping carts, and they also have specific items inside their shopping cart. So customer one here, they have here bread, butter, and milk. Customer two also has bread, butter, and milk alongside cereal. And customer three also has bread, butter, and milk. Customer four has sugar and eggs. Okay. In association rule, no, you create a model. So applying this example, no, and using this data set, and I want to create a model for it. I can tell the model to say that, hey, if a customer buys milk, does it also mean that the likelihood of them buying bread and butter is high? So based on my given data set, I have four here. There is a 75% chance that this is feasible. Okay? So um, that is what association rule is. Based on one key feature, you associate it into another feature. And how are these two features related with each other? Okay, in my engineering folks here, you are also familiar, say, just to give you another illustration of it or an analogy of it. You know what Ohm's law is, right? So we know that Ohm's law, we say that voltage is um, proportional to the current and resistance, right? Or if you want to spin your formulas around or work your formulas or equations around, we can also say that um, current is inversely proportional to resistance. So in other words, no, current is associated to resistance, but they are inversely related. So meaning if you have a given value of if your current is 0 amperes, what does it mean that your resistance is in ohms, right? So you're trying to find an association between two features or two or parameters. So that is what association rule is. Okay. So there. So these are just four of example classifications and use cases wherein machine learning is being used nowadays. Okay. And in fact, there are even others. No? And clustering, regression, classification, association, these are just the four basic ones. No? And some algorithms and classifications can even implement both, right? So that is machine learning so far. No? I'll take it one step further still and now discuss to you what is deep learning. So recall in my previous slides a while ago that AI, a subset of it is machine learning, and deep learning is a subset of machine learning is a subset of AI, whereas deep learning is a subset of machine learning. Okay. And I mentioned also here a while ago that it is an approach to machine learning. Okay. So what is deep learning first? No? Deep learning is a part of machine learning that uses artificial neural networks or a network of artificial neurons to learn from large amounts of data without explicit programming. So notice here again, no, the key term that is used for machine learning is still there, wherein it doesn't need explicit programming. You just call a model and that model is able to perform its thing. Okay, these networks are inspired by the human brain in terms of structure and in terms of practical use cases. No, deep learning is normally used for large, and when we talk about large volumes of data, we can also think of it as a matrix of data. And these matrices can come in the form of your images, such as your pixels, no? Speech, which is your digital signals, and language, which is more comprehensive than both. Okay? Deep learning needs lots of labeled and unlabeled data and powerful processors in order to produce a result. That is also why for a hobbyist, no, if you want to create a use case for AI, the most common practice is that you just get a model or instantiate a model that is already pre-existing from a given platform or from the internet. If you are familiar with Python programming, this is where platforms such as TensorFlow, PyTorch, and Hugging Face will be coming in, wherein it's just a matter of creating or instantiating a model based on whatever platform that you have in Python. So say for instance, if you are working with Hugging Face, by the way, if you are not familiar with Hugging Face, this is a platform that is normally used for speech recognition or computer vision, natural language processing, among others. No? And it doesn't just work with Python, but it also works with other languages such as R and even Ruby. No? But I digress. No? Um, if you want to create or if you want to use a model, a deep learning model from Hugging Face, all you have to do is to instantiate that model, call it as a transformer from the Hugging Face website, no, and place it inside your Python code. So you don't need to necessarily create a um, deep learning model in order to use it. There are already pre-existing ones. And in fact, no, these models are also fitted based on the use case that you want it to perform. Later on, I'll be showing to you. But going back here into deep learning, so it's mentioned that it uses, in terms of its structure, it uses what's called an artificial neural network. And it took its inspiration from the typical biological neuron found in the brain. No? So just a caveat here, I am not a medical professional, so please bear with me. But if I'm going to explain to you what a neural network or an artificial neuron is, we need to dive a bit also on biology. No? So my apologies. Like what I've said, no, AI already spans across several sciences, including also medicine. But here we go. Okay, so what is a neuron? So again, my apologies here. If I ever offend somebody from the medical field, I apologize in advance. Please bear with me. So my point here is that a biological neuron, in terms of its structure, you have here your basic parts. No? So a typical neuron would contain what is called a soma. And within that soma is where your nucleus would be coming in. The soma is considered as the main body of the neuron. This is also where the actual electrical pulses from the brain is being processed. Okay? Now, the soma extends into what's called axons and its terminals or branches. So the axon, in terms of physiology, it is used by the soma in order to connect to a adjacent neuron. No? So this is where your connection would be coming in. Okay. Then finally, you also have your dendrites. So the dendrites, these are the fibers that are used by the soma in order to receive signals from other neurons. No? So coming from a computer science perspective, we can now see that a biological neuron has three basic parts. No? The dendrite, which is used to receive inputs, the soma, which is actually used for the actual electrical electric pulses or processing or what have you. And finally, the axon, wherein after it has already been processed, it is passed to the next neuron. Okay, so translating this into what an artificial neuron would look like, no, in a logical perspective, no, the dendrites now would serve as your input layers, no, and these input layers can be considered as your input variables, or it can even be outputs from a previous neuron. Okay, each input layer is then given a weight. Okay, and all of these weights and layers are then consolidated as your summing junction. So this is where your math would be coming in. And it is also given what's called a bias. Okay? And taken as one whole, or quote unquote your soma, this is where your activation function would be coming. Okay? Then from there, it is then passed on into your output, wherein if you have another layer or another artificial neuron connecting to this existing one, no, it is then considered as the input layer of that next, or the um, input point of that next layer. Okay, so notice here that during my discussion of deep learning, we are also dealing with layers. This is because in deep learning, you are also structuring your model to have a layered architecture, wherein each of the layer would consist of your artificial neuron. Okay, so that's a bit of a lot, no? So how does now deep learning come into play? And you'll notice in terms of its use case, it is used for handling large data sets, no? And if say you are working with images and pictures, no, you can represent a given picture into your pixels, and the pixels themselves, no, notice you do not have a one by one pixel by one pixel image, right? So normally you would have, say, an array of pixels, and you want to, say, identify certain values or certain portions of your picture based on the values in the pixels themselves. This is where deep learning would be useful. Okay? So, how does a typical deep learning workflow, or how does an artificial neural network process its data? So I'm just going to give you a brief summary. No, so neural networks, this is usually described as having different layers, as I mentioned, no? And it can consist of several parts. No? You have there your input layer. This is where it picks up the actual data that you want to work with. And connected adjacent to it are your hidden layers. This is where the actual neurons would be coming in. And depending on the complexity of the model that you want to work with, these hidden layers can have one, two, three, or several thousands of layers inside. It is called hidden layers because you, as the engineer or the data scientist or the analyst, you don't really care much on what is going on inside the layers. All you have to do is to give it a input, and from there, no, understand how the layer is able to produce a desired output. You don't really care much on what is going on inside. Okay. But if I were to oversimplify what a hidden layer or an activation function would consist of, no, in some references, it would refer back into your linear regression formula, wherein you have y is equals to mx plus b. Okay. The only difference here is that y is considered as your layer, or the output that you want to produce, regardless of whether it is found inside the hidden layers or as the output layer. Your slope here would be considered as your input weights, okay? And then the intercept would be considered as your bias, okay? So notice that even though we have implemented a somewhat complex machine learning approach using neural networks, no, it still boils down into a simple formula. Y is equals to mx plus b. Right? This is just a different approach on how you use the same formula. Because unlike before, wherein it is just really as a formula, no, in a neural network, you can consider it to be a formula of formulas of formulas. Okay, so it really depends on the complexity. So just to give you a quick workflow on how a neural network would be working on, no? So here's a typical example. Suppose, say, you have an image of the face or the facade of a car, and you want to just tell the neural network where is the license plate located and what are the digits found inside the license plate. Okay, so for us as human beings, we can immediately tell it na, okay, so this is the facade of a car. Normally, the license plate can be found where? On the lower part of the car. My apologies also, I'm not a driver, but from what I understand, no, the license plate is normally found below or underneath the face of the car. I'm sorry. No? So you know where a license plate is. Okay, normally, and this is represented as an image, and it is represented by an array of pixels. So say for instance, you have here a 28 by 28 pixel image, then you can already identify its specific location where the license plate can be found. Okay, now the individual pixels themselves are actually transformed, no, and passed as inputs into your neural network. Okay, and they are also worked on, okay, and based on the model that you want to work with, no, weights and biases are also fed into each of the pixels, no, and then they are eventually passed around inside the hidden layers. This is where a functionality called feature extraction would be coming in. Okay? From the term itself, feature extraction, you're trying to identify which of these pixels can I find the exact location of my license plate. And take note that the license plate image itself, it's not represented only as a single value. It is represented by a series of values. No? And in math speak, this is also where your matrix would be coming in. It is represented as a matrix found inside a matrix of your pixel of images. So you see now where your complexity would be coming in. No? So as each of the layers are being worked on, no, the data set here or the signal flows within the layers. The weighted sum is also calculated and it is fed to the activation functions into each of these said layers before it is passed on to the next layer. So to simplify this term, it just means that once a given neuron has already given a specific calculation to one pixel, it is passed on to the next hidden pixel. Okay, and this cascades across the entire architecture until it reaches the endpoint or the output, wherein it doesn't just stop there, because after which another process happens wherein all of the values in your matrix is processed is what's called backpropagation. And the reason why the neural network does this is because, of course, there are some errors that can be found in the individual pixels. So this is more of like error detection or calculation being done. Okay? So there. Now, again, no, I just gave you a simplified approach or a simplified explanation on how ANN and even deep learning works, no, in general. But I hope you were able to understand at least the concept of it. No? So this is also where other algorithms will be coming in, such as your naive Bayes, your convolutional neural networks, and so on and so forth. Okay, so having already discussed supervised learning. By the way, I forgot to mention, no, deep learning is also an approach. So meaning you can implement regression, classification, clustering, association using deep learning. Okay? So it's not really an umbrella wherein I can just use supervised learning for clustering. No, you can even implement clustering using deep learning. Okay? So my point here is that regardless of what algorithms or approaches that you have, despite the myriad approaches to it, there is really no one-size-fits-all algorithm when you are working with data. The main objective on why we are presenting you on these different approaches is that you can already identify how do you need to work on with your data. Okay? You also need to have a bit of an understanding on the type of data that you want to work with, right? So say for instance, you're trying to predict the value of what would be the price of 1 kilo of rice in the next 3 months. You do not use clustering, of course. So you use regression. Okay? So this is just my point here. And because machine learning, it is still tied up to your computer science and in a way also inclined to your data analytics, it still follows the workflow on how you process your data. Meaning that the model would only be as good as the type of data you train it or not train it. Okay? So again, before you can, as a common practice, not just in the academy, but even in the industry, when you are working with data, you also have to pre-process it before you can even feed it into your model. So it's really no exemption here. Okay? So I've discussed to you the different approach of what machine learning is, as well as give you an understanding on the different algorithms. I've also taught to you a brief history on what AI is in general, its promises and its aspects and benefits, among other things. I essentially glamorized the technology for you in a way and gave you a academic perspective on what the science is about, no? And because it is a science, we also need to understand that it is not all butterflies, unicorns, and rainbows, as the saying goes, no? It still has its own limitations. And I believe you already also encounter this in your day-to-day life, especially what you hear in the news and in social media. So what are the limitations of machine learning? The number one, arguably the number one limitation, is its implication to ethics. Okay. AI algorithms can only be as efficient as the type of data that you give. Okay. Now, having said that, no, data can be biased as much as you want it to be. Okay? So AI systems can also raise concerns about data privacy and security. How you acquire said data from in order to train your models. If you are familiar with the given tech news nowadays, I believe um, there are already some companies nowadays who are intentionally, no, but discreetly taking user data in order to train their models. No, I won't be naming companies here, but I think you are familiar, especially if you are in the creative space. Now, there are some individuals, hobbyists who are boycotting in a way the use of some platforms because of how unethically they are using the the end use their end user or their customers data in order to train their models. No, so this is where ethics is really an issue. No? Another one is deterministic problems. No, AI and machine learning excel at finding patterns, but again, it is a limited system. Okay, meaning that it can struggle with problems requiring reasoning, common sense, or dealing with entirely new situations if it is not fed with the right data. So really, no, your machine models and your AI systems can only be as good as the type of data that you feed it. I keep on stressing that. Okay. So I think if you are familiar, say, I mean, almost all of us here have already used, say, Chat GPT or Google Bard or even Copilot if you're a programmer, that there are sometimes instances wherein you give the chatbot a question and the answer seems off. Right? So say for instance, you give it a statistical question and instead of producing a result, it tells to you how or the process on how the calculation is being done. So that is one limitation. Another one is correctness and completeness of data. So this is where the importance of pre-processing your data is really coming in. No? Inaccurate, incomplete, or biased data can often lead to unreliable and even potentially harmful outcomes and outputs from the system. So just to give you an example, I believe this one I can somewhat also explain to you. There was an instance where in ChatGPT um, was raised an eyebrow, if you know what I mean, wherein some of the users or some of the users in general, type the query of generate an image of the Pope for me, no? And what ChatGPT did was it generated an image, but instead of producing an image of the current Pope, so we know who the Pope is right now, no? Um, it produced a different result. So we know that the Pope is a male, white, possibly European or of Latin origin. So we know who Pope Francis is, right? And we are already anticipating that ChatGPT is able to produce an image that is akin or almost similar to Pope Francis. But instead, it produced a female Pope, a person of color, okay, doing something else that is quote unquote unpopely. So immediately there, the question in OpenAI is raised, wherein where did ChatGPT learn that the Pope looks something like this? So it still depends on the type of data it is based on. Okay, and having said that, already the concept of generative AI already, the misuse and misapplication of AI is also there. So AI technologies can even be used to create deep fakes and in order to spread misinformation. If you are familiar with social media, I believe that's already circulating here nowadays, something a bit more wholesome, no, if I'm not mistaken, no. You would be able to see there a generated conversation between Kim Kardashian and Nicki Minaj explaining the importance of linear regression in statistics. I mean, what the heck? No, my point here is that it's not really misuse and misapplication, but definitely something that is misinformation, right? Since when did you were able to see Kim Kardashian and Nicki Minaj explain statistics to? I mean, hell. So there. And finally, interpretability. So many AI models, especially deep learning models, can be complex. No? Remember what I have discussed about deep learning, that especially in the hidden layers, you don't really need to understand what goes on in the hidden layers themselves. But if you want to optimize how the model is able to perform, you really need to go deep dive and comprehend how each of the given artificial neuron is able to produce its activation function. Okay, so this lack of interpretability can often hinder trust, especially if, say, a given company or institution is starting to work or to incorporate AI as part of their repertoire of solutions. Because definitely the question of how trustworthy will your product or AI given product is to the general masses. So it leads to open interpretation. Okay? So really, no, what I'm giving to you here as a picture is that AI is not really that it's a technology that is still not yet completely there that it would take over the world and overrun humanity and be the dread of us all, no? But the questions on how it is being used ethically and morally is already there. Right? I mean, the question of ethics and morals here is not really much on can an AI be considered a human, but the true question here is that how can we morally use or how can we use AI systems for the betterment of everybody? Okay. So we discussed a lot, no, in the next an hour and a half or so, and these are just the high level summary, and this is just again the tip of the AI iceberg, if you know what I mean, no. But just to give you a quick recap, we've discussed that AI, this is a broad field of computer science, no. It deals with the creation of systems that is able to mimic intelligent beings or intelligent entities, human or otherwise. It started off as a concept as early as the 1950s, but gained widespread popularity somewhere around the early 2020s. Okay, with especially the onset of companies such as OpenAI and Google and even Microsoft. No? AI covers a wide range of fields in sciences and fields, some of which can even go beyond the sciences, such as the philosophy and even the arts. No, machine learning can be considered as a subset of AI that deals with creating algorithms without explicit programming, and an approach to machine learning or a subset of which wherein you can perform without explicit programming but implement it using neural networks is what's called deep learning. Okay. And like all technologies, I mean, not just here in AI, but in all of the topics we have discussed here, no, in the last few weeks, no, as a technology, it can offer its benefits, but it will also have its limitations. The main objective here or the main takeaway here is that what is the overall net positive that this technology is able to produce to society as a whole.